Hi, in this video we will discuss compression-aware pruning. We will see what compression-aware pruning is and we will also go through a simple example to see how it works. Basically, in compression-aware pruning, what we do is that we remove the neurons that have minimum weights. And this is based on the assumption that the neurons that have minimum weights, they contribute minimum toward the inference by the final model. So the neurons that have minimum weights, they are contributing so much minimum that their contribution can be neglected. So this is the pruning process. Now this pruning can be performed at two stages. First, either during the training process, and secondly, after performing the complete training. We will see the pruning during the training process. First, let me tell you that to perform compression-aware pruning, we need to have a fully trained model. This can be your own model trained by yourself on your own data, or you can take some pre-trained model as well. Now suppose that this is our model that is already trained. As you can see that there are 3 neurons in it and we have 2 inputs. Now just for the sake of understanding, let's go through the first pass on this model. This one will be multiplied by this 5 to get 0.5. Similarly, this 2 will be multiplied by this 0.4 to get 0.8. So 0.5 plus 0.8, we will get 1.3 here. Now this one will be multiplied by this 0.1 to get 0.1, and this 2 will be multiplied by this 0.025 to get 0.1. Now this 0.1 plus this 0.1, we will get 0.2 here. Similarly, this one will be multiplied by 0.6 to get 0.6, and this 2 will be multiplied by this 0.7 to get 1.4, and 0.6 plus 1.4, we will get 2.0 here. Now this 1.3 will be multiplied by this 0.8 to get 1.04. Similarly, this 2 will be multiplied by this 0.2 to get 0.04. 1.04, this one plus 0.04 by that we get by this multiplication. Similarly, this 2.0 will be multiplied by this 0.9 to get 1.8. So here we get 1.8. So overall our predicted value will be 2.86. Now suppose our actual value was 2.75, but we have predicted 2.86. So we are off by 0.11. So this is the error. Now this was our first pass on this model. Now let me remove these values. Now in pruning process, what we'll do is that we select the neurons that have minimum weights and we remove those neurons. Now if you see, our H2 neuron has the minimum weights. What we will do is that we will make its weights as totally 0. This means that this neuron will not participate in the inference process further on. But let me tell you that after making its weights as 0, we will continue our training so that the other weights are updated to compensate the knowledge that has been eliminated by removing this neuron. Let me repeat it, that we will select the neuron that has minimum weights. We will remove that neuron by making its weights as 0, and we will continue the training process so that the knowledge that has been eliminated by the removal of this neuron could be compensated or could be gained by other neurons during the training. Now let me clear these values. Okay. Now what we do is that we will continue the training process. Now suppose that we perform the training again by keeping these weights of the H2 as 0 and updating the remaining weights. Now suppose that remaining weights updated to these values. This became 0.52, this became 0.9, 1.0, 0.7, 0.8 and 0.5. Now if we perform the further pass again, you will see that we get the new predicted value as 2.73, whereas our actual value was 2.75, which means that now we are off by 0.02. This means that our loss has decreased and our accuracy has increased now. Now this is the complete pruning process. What we did was that we started with the complete neural network model that was already trained, or you may say that was fully trained. Then we pruned few of the neurons, and then we continued our training so that the knowledge that was eliminated by pruning that neuron could be gained by the other neurons. Now, after this, our new model becomes this one. As you can see that previously we had H2 here, now that has been eliminated. Now our new model has shorter neurons as compared to our original model. Originally we had 3 neurons, but now we have 2. Now this will give you the complete picture. We started with the fully trained model. We eliminated the neuron that was having minimum weights, and then we continued the training. And once we continued the training, you can see that the previous weights have been updated. This 0.5 became 0.52, 0.8 became 0.9, 0.4 became 0.5, and 0.9 became 1.0. This 0.7 became 0.8, and similarly this 0.6 became 0.7. If you see that after eliminating this neuron, the information that was lost by due to the removal of this neuron has now been gained by the other weights. So our information is not lost, but our model has learned that information through fewer number of neurons. So our new model becomes this one. And as far as accuracy and other parameters are concerned, those will remain the same almost. Now this is an example of pruning after training. What you do here is that you train a model and you simply remove the neuron with minimum weights, just like this. We have removed the neuron with minimum weights, and the remaining weights are not updated. This means the knowledge that has been lost by removal of this neuron will not be gained by other neurons. So this will result in lesser accuracy. The accuracy will be compromised. But in our previous case where we pruned during the training, the information that was lost was gained by the other neurons during the weight update. Now these are the benefits of compression aware pruning when it is performed during the training process. The compression aware pruning results in smaller models. By smaller models we mean that the model will have less number of the neurons as compared to the original model. And smaller models will definitely use less memory. Their inference will be fast because now we will have less number of computations. And as far as accuracy is concerned, it will be maintained in most of the cases, and we will have accuracy almost close to the one that we had in our original model. So this was our compression aware pruning process that is performed during the training of the model. Thank you.